Now let's look at the topic of vertex cover, in which we are going to see minimal vertex cover. So see this, it is a vertex cover from which we cannot remove any vertex. So what does it mean is, once you form the vertex cover, sometimes what happens is it might contain vertices which might not be required, right? So in that case, that is not called the minimal. So if you have a vertex cover from which you cannot remove any vertex, in case if you remove any vertex, it should not be the vertex cover. If that is the case, then that is called as minimal vertex cover. For example, if you see this one, so let us say this is the graph we have, and now in my vertex cover I have included, what are the vertices? 1, 2, 4, 5, 6. This one is not minimal. What is the meaning of it? See this, if I include 1, 2, 4, 5, 6, I cannot call this vertex cover as the minimal vertex cover. The reason is 2 is not required. If you see if 1 is required, because if I delete 1, there is no one to cover this edge 1, 3, right? But then if I delete 2, still I am going to get a vertex cover which is going to cover the entire, all the edges, isn't it? If I delete 2, 4 is covered. Okay, 3 is not covered, right? So I think I cannot delete 2. 2 should be there, right? So if I delete 2, 2, 3 will not be covered, right? So if I delete 4, yes, I can delete 4 because this edge is covered by 2, and I can delete 5 as well because this edge is covered by 2, and I can delete 6 as well because this edge is covered by 2. Therefore, by including 4, 5, 6, this particular vertex cover is not minimal. Now whatever you got, 1, 2 is minimal, isn't it? Why? Both 1 and 2 are definitely required. If I delete 1, there will be no one to cover 1, 3. Right? If I delete 2, there will be no one to cover all these edges. Therefore, these two are definitely required. That is why it is called as minimal. Got it? Now see this. In this case, we have 1, 3, 4, 5, 6. Right? Now if I delete 1, there will be no one to cover 1, 2. Therefore, 1 is definitely required. Now if I delete 3, there will be no one to cover 2, 3. Therefore 3 is definitely required. If I delete 4, there will be no one to cover 2, 4. So 4 is required. I can't delete 5 because there will be no one to cover this one. I can't delete 6 because there will be no vertex to cover this. Therefore all these are definitely required. I cannot delete any vertices from this set. Therefore it is called as minimal vertex cover. Got it? And what about this one? 2, 3. So I can't delete, see now this vertex cover is 2, 3. Now I can't delete 2 because if I delete 2, there will be no one to cover all these edges. If I delete 3, there will be no one to cover 1, 3, right? Therefore 2, 3 is the minimal set. Got it? So this is called minimal. Now there is something called as minimum cover. So minimum vertex cover is the vertex cover with the least number of vertices, right? If you see this is minimal, which is containing 1, 2. This is minimal, which is containing 1, 3, 4, 5, 6. And now this is also minimal. Out of all these minimal, the least one is 2, isn't it? Either this one or this one. So what can you say? Now we can say that the number of vertices, the minimum number of vertices required in order to cover this entire graph is 2. Therefore, this is called as the minimum vertex cover and its cardinality is 2. Okay. Now, how am I sure that this is the minimum? Because if this is not the minimum, then I should be able to get a vertex cover which contains only one vertex. But if you see this, clearly I cannot take any one vertex and I cannot cover all the edges. If you feel that we can take only 2 alone and if you can cover everything, it is not possible because this particular edge will not be covered, right? If you feel that I can take 3 alone, it is not possible because these edges will not be covered. Got it? Therefore there is no possibility of getting a vertex cover of size 1, right? Therefore we cannot have any minimal vertex cover which is containing one vertex. But then if I go to size 2, yes, we got many options. Therefore the minimum vertex cover in this example will contain at least 2 vertices. Now if you observe this, the minimum is not unique. That is very important. So the minimum vertex cover need not be unique, as well as minimal vertex cover need not be unique. Why? All these are minimal, then 2 are minimum we got it. So both of them need not be unique. Now what can you say about the minimum vertex set, minimum vertex cover? The minimum vertex cover is always minimal, but the minimal vertex cover need not be minimum. Are you getting this? The minimum vertex cover is always minimal, which means you cannot delete anything from it. If you can delete it, then it will not be a minimal, isn't it? So the minimum vertex cover is always minimal, but the minimal vertex cover need not be minimum. Got it? Okay. And now finding the minimum vertex cover is a NP complete problem. So what is an NP complete problem? We shall discuss about NP complete problems in algorithms. Okay. So don't worry about this here. Since the topic is there, I have written it. Okay. Fine. Let's see few more important points on matching. These points will be useful for you to solve some of the questions in GATE if they ask you. So one important point is obtaining a matching and a vertex cover of the same size proves that each is optimal. So which means in this example, if you observe it, I got a matching of size 2, right? This one and this one, and also I got a vertex cover, okay, of size 2. So whenever I get such a such things, then I can say that this is the maximum matching, or size of the maximum matching is equal to 2, and this is the minimum vertex cover, which means size of the vertex cover, minimum vertex cover is 2. So whenever you get such things, then you can declare it. Got it? So even in this example also you can see it. Here also we got a matching of size 3 and a vertex cover of size 3. What does it mean? This is the maximum matching and the minimum vertex cover, right? So that is what this point says. So you can use these points in order to verify whether your answer is right or wrong in the exam, right? Okay, and the next point is maximal matching is less than or equal to minimal vertex cover. So this point we have already, I already explained you this point in earlier videos. I told you that the vertex cover should always be greater than or equal to the matching. The reason is, you take any matching, you are supposed to cover all the edges in that matching, and so you have to include those many vertices, right? And in order to cover the remaining edges which are not in the matching, you might sometimes have to include more vertices. Therefore vertex cover will always be greater than any matching, and minimal vertex cover is nothing but a vertex cover, isn't it? So minimal vertex cover should definitely be greater than the number of elements. Minimum vertex cover should definitely be greater than the number of edges in any matching, right? So even I say any, you can put maximal, because maximal is also one of the matchings. Got it? And the second one is, this is interesting, see this. Now if you take any maximal matching, then the minimal vertex cover is less than or equal to 2 into maximal matching. So what it means is, in worst case, you should be able to cover all the edges by taking all the vertices which are present in the matching. Try to understand this. In worst case, you should be able to cover all the edges of the graph by taking all the vertices which are present in the matching. See, if you don't understand it, leave it. It is not required. I am just giving you for the sake of understanding, right? So what I mean to say is, let us say you have a matching, right, which is a maximal matching, right, which means there will be some edges in this. Okay, now how did I get these edges? From some graph. Okay, let's say some graph is there. Now by taking all these vertices, I should be able to cover all the edges which are present in the graph. If this is not true, then what does it mean? It means that there is at least one edge in the graph whose both endpoints does not belong to any of these vertices. Then according to the definition of maximal matching, you could have included it and you could have made the matching bigger, and therefore this matching would not have become maximal matching at the first place. Got it? Therefore your minimal vertex cover should always, in worst case, should not grow beyond this. Okay, so if you are able to understand it, okay. If you didn't understand it, leave it. Just remember this point, right? I don't think that any questions will be asked on these complicated points, but if you can understand it, it's okay. Otherwise, leave it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.